To solve this exponential equation, it's exponential, right, because the variable's in the exponent. Let's take the log of both sides, right? You undo an exponential with its inverse, which is the log. So I'm going to take the log, and I'm going to choose to take the log base 10 because that's on my calculator and it's easy to work with. I'm not even going to write the 10 anymore, right? Just a common log. So log of 5 to the negative x is equal to the log of 12. Now, using the properties of the logarithms, I can bring that negative x down in front, right? Bring the negative x, the exponent, down in front as a multiplier. So how about negative x, log of 5, that's equal to the log of 12. And now I can get close to x if I divide by log 5. So I'll get negative x equals log base 12 divided by log base 5. And then why don't I just multiply both sides or divide both sides by negative 1. So we'll get x equals negative the log of 12 over the log of 5. Now I will do this all at once on my calculator. I'm going to type in the negative sign, not the minus sign, right, the negative key. And then I'll press the log key. And then I think you automatically get a parentheses with that. So I'll put in a 12 and I'll close the parentheses. Press the divide key. Then I'll press the log key again, parentheses, put in a 5. When I do that, I'm coming up with this, negative 1.54395, dot, 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 keeps going. So I'm going to round off here, and I'm going to claim that x is equal to negative 1.54395. Yeah, but now as I do that, I could see I could round this up here, right? That's a 5 over here. So I'm going to claim actually that x is equal to negative 1.540. Now let's just look at this again. All right, this is 5 to the negative x equals 12. When we did this, we conveniently used log base 10 because it's on the calculator. We could have used natural log. Would have been the same thing. Instead of logs, it would have had ln's. But what about here if we take the log base 5? After all, the base is 5. Let's just see what happens here. So if we take the log base 5 of 5 to the negative x, this would be the log base 5 of 12. And then on the left side, these two bases match. So they undo each other. This logarithm base 5 undoes the exponential base 5, and I just get negative x equals log base 5 of 12. Well, we thought maybe we had a shortcut here, but look. See, I've got the log base 5 of 12. I don't know the log base 5 of 12, and I've got an old calculator. It's not on my calculator. Maybe some of the newer ones you can put in a different base other than 10 or e, but not on mine. So I would have a little problem here. So what I'd have to use now would be the change of base formula. So I would have negative x equals, now here's how the change of base formula goes, at least the way I remember it. You get two logarithms. You get one on the top, one on the bottom. Now the one that you put on top is the log of, say, the top number. The one you put on the bottom is the log of, say, the bottom number. And it's a convenient base that you want. So I'm going to use base 10 because it's on my calculator. So I'm going to write this as log base 10 of, now the number that appears, say, I got 5 and then a 12. 5 down, 12 up. I'm going to use the up number. And then the log, now since I'm down in the denominator, I'll use the down number. Now look where we are. We're right here. Negative x equals this log of 12 over log of 5. Look where we were back over here. Oh, actually right here, right? It's exactly the same thing. We thought we might get away with a shortcut because we use the same base, but all in all, we end up at the same place. So no time saved.